How many more of these videos do we have to do? Oh, it's on? Today we add and subtract rational expressions with common denominators. Really excited to make another video for you. Mercado math,
Longest
Mercado math.
title
It's time to do
ever.
some math. Let's Merca do it. Alright guys, today we are adding and subtracting rational expressions. Once again, rational expressions are basically ugly fractions, so like I said in the last video, you can add them, subtract them, multiply them, divide them. Today we're adding and subtracting. The key here is we will have common denominators. If you remember how fractions work, common denominators make life easier. When they have different denominators, life gets a lot harder, especially when they're ugly fractions, rational expressions. So let's start off with this one. These two should make a lot of sense and feel real simple. The same denominator should be simple. Here's the first one, real easy. When you have a common denominator, you write that common denominator. 4x to the third, 4x to the third. This would also be 4x to the third. Common denominator, they all have it. The numerator is just 9 plus 3. Since we have the common denominator, I just add 9 plus 3 and I get 12. It's that easy. Now we're not done, but it is that easy. Now that we have this, just like we've been doing, you always look, can I simplify? You kind of should be used to that. Between radicals, slope, every time you get a number, you should always just look, can I go any further with this? And you could. This is something I said, you've been doing these for a while, not even this chapter, chapter 7. 12 over 4. You can reduce those regular numbers. 12 over 4, if that x to the third wasn't there, is 3. This becomes 3 over x to the third. This is your answer. Excluded values are still a thing. No one talks about them when you're doing all this other crap. But yeah, technically, x can't be equal to 0. All right? You don't always see that mentioned, though, every single problem. But that's our answer. Once again, 9 plus 3, 12. Common denominator, common denominator, common denominator. Once here, I was able to simplify 12 over 4. If you want to try this one, pause the video, try it on your own. It should go very quickly. I'm going to do it now. They have a common denominator. That's today. It's going to be that easy. 10x squared y to the third, 10x squared y to the third. 10x squared y to the third. 7x minus 5x is 2x. Once you have that, you can simplify. And once again, I already know I'm going to have to simplify. The moment I see 2 over 10, I'm like, oh, that's 1/5. 1x up top, 2 on the bottom. Where do you have more x's? On the bottom, how many more do you have there? 1. You still got 3 y's hanging out, so I put those 3 y's there. I need the 1 up top to hold the place, so I'm going to leave it there, and this is my answer. Maybe a few you might have noticed, I could have simplified the x's here. I didn't do that because if this didn't have that x there, that would have screwed up the denominators. Remember, your goal is to have common denominators. If you have common denominators, just go for it. Simplify at the end. Don't try simplifying and then going. Your life's going to get a little bit harder that way. Let's move up a level. This is more of a higher level. And it's not just because there's a binomial in the denominator. That could be just as easy. In fact, I'll do an easy one after this. But this is already a solid medium. So let's start it. Common denominator, x plus 3. In fact, actually, we're going to go down here, x plus 3, because we're going to need a good amount of space for this one, and you'll see why. Subtraction. This subtraction is always going to be a little bit harder because when you write this, it's 4x squared minus 11 minus 3x squared minus 2. You are distributing this. Just like when you subtracted polynomials, you had to distribute that negative. You're still doing that. So this becomes minus 3x squared and minus negative 2 becomes positive 2. Okay? That's our problem. Distribute the negative. When you have subtraction, you have to distribute that negative. That's a key part. This is honestly the only thing that can make something like this a little harder, is forgetting that. And if you would forget it in chapter 7, you're probably going to forget it now. So hopefully you're paying attention and you made it to the video this far and you're like, oh crap, yeah, I kind of remember that. If you want to remember what this used to look like in chapter 7, I'll write it and erase it real quick. This is what they used to look like. They used to have parentheses. They would look like this. That's essentially what you're doing. You're subtracting a binomial minus a binomials, polynomials, and you would distribute that negative. That's what you used to do. This is the escalation of it. So now that I have this, it's just combining like terms. So I'm going to combine like terms. Common denominator, I still have that common denominator, so I'm still going to write it. No reason to change it yet. X plus 3. 4x squared minus 3x squared is x squared. Negative 11 plus 2 is a negative 9. And maybe a few of you see it already. And if you saw it already, and you already know what's going on, yeah, good for you. Difference of squares. Remember, you always look to simplify. We are always looking to see, can we go further? Can we break it down? Can we simplify? Do we always have to? No. Do you always have to look? Yes. Difference of squares. This factors to an x plus 3 and an x minus 3 over x plus 3. And of course, at this point, I think everyone knows, these simplify, cancel out, and your final answer, x minus 3. This whole subtraction problem just equals x minus 3 once you're done. That is a harder one, but if you really think about what you're doing, it's mixing old skills together. You are subtracting polynomials. That's not anything terrible. You distribute the negative and your life's easy. If this were addition, you fly through it. Once there, we had a factor. Difference of squares, that's a good one to factor. Is it always going to be difference of squares? No. But this one was, and that's kind of nice. And then we simplify, cross some stuff out, you're good to go. All right, let's do another one. It'll be addition. Let's keep going. Here's a nice addition problem. So we have an addition problem. We're going to go, all right, common denominator, just write that down and get that over with. X plus 3. X squared plus 15 plus 8x. Addition is easy. You don't have to distribute. You just write down what you have. However, I am going to write things in standard form because I don't want to not see something. When things are in standard form, it becomes a little more obvious what's happening. So I'm going to go x squared 8x plus 15. And then once I'm there, you have to go, can I simplify? And hopefully you guys kind of see this and go, oh crap, yeah. Basic factor. The numerator, things that multiply to give you 15, add up to 8. X plus 3, x plus 5 over x plus 3. Once you're there, yep, these cancel out. Whole thing equals x plus 5. And just a reminder, excluded values are a thing. However, you don't always have to write x can equal negative 3. That's not something you have to deal with. But x plus 5, and you're done. This is ready to go. I'm going to give you a few to try on your own after this. And there'll be a mix. I'll still go over them. Just if you wanted to practice, these were ones to practice on. So here are two problems, ready to go. This one and this one, they're not easy, either of them. They would both be, I consider, this is a solid medium. This is like a high-end easy problem. They both are going to involve some factoring. That's your hint. If you want to try them, go for it now, because I'm about to go over them. Common denominator, not anything crazy. 12n to the 7th, I write 12n to the 7th. 6n minus 10 is just 6n minus 10. And as of right now, it looks like you can't do anything here, except you have to remember a certain type of factoring, GCF. 6n minus 10, I can take out a 2. That leaves me with a 3n minus 5 over 12n to the 7th. The 2 and 12 you can simplify. So you reduce 2 by 12, you reduce them by 2. That's kind of what reducing is. And your final answer, 3n minus 5 over 6n to to the 7th. That is the ugliest 7 I have ever written. I am sorry. I apologize. You don't really give a crap, neither do I, but there it is. I'm really not sorry. If you don't like my 7s, who cares? It's June. This one. Same denominator, same denominator. I'm going to write my same denominator. X plus 2. Now the numerator's got a little more going on for it. It's subtraction of a polynomial. You have to remember this negative gets distributed. You don't really think about distributing it here, but remember, it kind of is. It's minus 10. That's what happened here. This is minus 7x, minus 8. So I'm going to rewrite everything. X squared minus 10, negative 7x, negative 8. Once again, if you don't like that 7, screw you. We keep on going. I have some like terms I'm going to deal with. We're going to go down here. I still have the x plus 2. That's my common denominator. Notice, through all of this, the denominator is staying the same. X squared, nothing for x squared. Negative 7x, negative 7x. And I have a negative 10 minus 8. Some like terms. That's negative 18. That's going to be basic factor, that numerator. Things that give you negative 18. I haven't done this in a while, so let's make the list. I haven't made the list in a while for the numbers. Things that give you 18. 1 times 18, 2 times 9, 3 times 6. You want a negative 18, which means one's positive, one's negative. You want them to add up to a negative 7, which means the negative is your bigger number. It's the dominant number. And then you play the game. Which of these will give you negative 7 to negative 9? So this factors to x plus 2, x minus 9. All that is over, x plus 2. And even though they don't always cancel, I have been making them cancel because I want you to kind of force yourself to always look to simplify. Gone, gone, and I don't have a big ugly answer. I got a really nice looking answer here at x minus 9. That's my answer. Looks pretty good. To be honest, this one that's easier has an uglier looking answer. Don't worry about what the answer looks like. Sometimes it'll be ugly, sometimes it'll look good. Just trust your work. If you didn't distribute that negative, you wouldn't have had this happen. If you forgot to distribute that negative, you had a plus 8 here. That would have screwed you up. You got a negative 2. This would have been stuck like this. So always be careful. The negative distributing is probably the most important part here. And like I said, it's something that you've done before. So the most important thing is something you've done before, all right? Let's get our pun done. What to draw, what to draw. That's not soup, that's tea, because you guys have been doing a pretty good job lately. That's not true. Not all of you have been doing a pretty good job, but I do think those of you watching these videos have been doing pretty good. And I have been making plenty of videos, and I am losing my mind. All right. Maybe I'll edit this out. Maybe I'll leave it in. Maybe you guys should see me falling apart. There is no cake. Mercado math, it's time to do some math. Let's Merca do it.